Good day, viewers. Now this is another projectile question I want us to have a look together. The question says a particle projected horizontally at 10 meters per second from a height of 45 meters. Calculate the horizontal distance covered by the particle before hitting the ground. And here we are given acceleration due to gravity g, approximately 10 meters per second squared. As usual, I will advise try and sketch if possible. Okay, now I'm going to try to do that here. Remember, this is the ground where we all stand, and here you have an object, a structure whose height is 45 meters. Now from the top of this height, a particle was projected horizontally. Projected horizontally means it's supposed to keep going this way. So initial horizontal velocity was given as 10 meters per second, right? But of course we know this object will eventually fall down to the ground. When it will start falling down, it's going to have initial vertical velocity 0. When it gets to the ground, to have the maximum vertical velocity. Now let's try and solve this problem. The height is 45 meters. Trying to bring out all we have. Acceleration in this case is acceleration due to gravity, because it's going down in the same direction as gravity. We're going to use it as plus g, which is 10 meters per second squared. What else was given? I think absolutely. Okay, we realize for the vertical motion involved, the initial vertical velocity is going to be 0. Now the question is, how do we find the horizontal distance the object moved from the base of this height to where the particle will land? That is the range under normal projectile motion. That horizontal distance is actually range r. We are looking for it. Now, I'm just going to say this. You need at least 2 steps to get this done. You need time of flight. If as soon as you get time of flight, you are good to go. So that means we need time of flight. We need it. If we use s equal to ut plus half at squared, right? This s becomes the height from where the object was released. Then the uy for the vertical movement, ut plus half gt squared. Remember, gravity affects vertical motion, so it's important here, and it's going to be retained. Height is 45. This is 0 times t, which will make here 0, plus half 10 times t squared, because we're looking for that t. So we have 45 equal to 0 plus half times 10 is 5, so have 5t squared. Yeah. So we have 45 equal to 5t squared, dividing both sides by 5. So we come up here, finish. 45 by 5 is 9, equal to t squared. So taking square root of both sides, we give t, which is time of flight, as 3 seconds. Now we've gotten this. Remember, we got this t considering the vertical direction of motion. Let's consider the horizontal direction of motion so that we can find the range. Equally using this, s equal to ut plus half at squared. The distance s is the range we're looking for horizontal direction. We're going to use ux initial horizontal velocity multiplied by t plus half. A is acceleration due to gravity, but it does not affect horizontal motion, so we're going to use it as 0. That's one of the conditions for projectile motion, one of the assumptions. Gravity does not affect the horizontal component of motion. So here we still have t squared, right? So here we have r equal to uxt. All of this becomes 0. So what do we do? Ux was given as 10 meters per second multiplied by time of flight 3. So we have r as 30 meters. I use this expression to make sure you understand how to apply the common equations of motion you know. But one thing I know some people always do is they will remind you that when you're looking for range, you need to know it is velocity times time. That since gravity does not affect it. But how will a learner know? A learner have to start from here to understand why. This g becomes 0 for horizontal component of motion. So you have this equal to only this part. You can solve it.